For those who are here at the first part of the presentation, I already told a little bit about the exhibition that you're all in, the exhibition that this conference Future Life is held in. That's The World Without Us. Maybe some small extra words, short extra words on A World Without Us. I already mentioned some of the inspirations, but I think I should also mention Alan Weisman's text, Earth Without People, as he first published it, and The World Without Us later, as it was published in the magazine Discovery. And if you want to read that text, you're invited to take one of the posters out there. The posters are part of a piece, an art piece by Maarten van der Einde called Zoology of Genetology. And actually the posters will become a book. Each chapter of the book is printed first as a poster, and it consists of both an artwork by an artist, in this case Maarten van der Einde's own collection of photographies, combined with a text, and in this case that's the republishing of this Alan Weisman text, Earth Without People, that I just mentioned. So please take one of those posters. Maybe just briefly going over and introducing to you the rest of the works in the exhibition. Of course, we already discussed ArchaeaBot that you can see there at the moment, and that's made by Alex May and Anna Dumitriu. Over there it's switched off at the moment, but it's a Mark Leckey piece that kind of visualizes the inner life of a fridge, like the proverbial Internet of Things object. And then there it's a 3D edifice cookbook that imagines plastic as a future species. Over there we have, let me check what the title of that piece is. Aquaforensic Underwater Interception of Biotweaking in Aquatocene by Robertina Sepjanis and Gino Sutic, and it's researching the waters of our ocean to try and get all the pollutants out of it and use those for the goods, for instance, to use medicine. That's Maarten van der Einde's piece, Homo Stupidus Stupidus. Kind of how any future species might find our skeletons and try to put the bones in order again. And there it's already partly dismantled because it has to go to Tallinn, unfortunately. It's a piece by Tavi Sutala, and it's called Waiting for the Light. Okay, we're going to now start with the second panel of this conference, the risks and benefits of AI. We're going to do it a little bit different, meaning that I will introduce each speaker more extensively just when they come to stage, but not at the beginning. Just briefly mentioning the participants now in their order of appearance on stage today, which is Anna Dumitriu first, and then we'll have Lucas Evers, and as the last person to speak in the panel, to give a presentation in the panel, we have Jan Broersen, and as I said, I will all introduce them more extensively to you when they go on stage. Then after about the three presentations, each 10 minutes, we'll have a discussion on stage, and of course there will be possibilities for you to ask questions on the presentations and on the themes that are on the table. And the themes on the table in this panel are questions like, but not limited to, can AIs make art? What are the limitations of machine learning and genetic algorithms? How can we control or legislate AI? Should AIs be given rights? And are AIs an existential threat to humanity? Well, I think that's a lot of ground to cover. And the first one that will make an attempt to do so is Anna Dumitriu. So if you please go on stage, please a welcome for Anna Dumitriu. Anna is, as I already introduced her in the at the beginning of the first panel, is one of the AMAP artists that made a new piece together with Alex May in this European network that IMPAKT is part of, and you can see it exhibited there. And Anna, her work has an international exhibition profile and has been featured in Wired UK magazine and The Lancet. The AMOP project that she made is ArchaeaBot. It has been produced in a residency in Gijón in Spain at Laboral, and it has already been exhibited at several places in Europe, amongst which Ars Electronica Festival and here at IMPAKT, of course. Please, Anna, go ahead.
Thank you. Yeah, it's lovely to be here again. So I thought I'd start off just mentioning briefly about ArchaeaBot, because the way it works in the context of my work is it's very much a fusion between two sides of my work. The biological, I have a huge focus on microorganisms and bacteria, particularly in my work, infectious diseases and that side of things. And this side of robotics in my work, and I've always been very interested in bringing these together somehow. So there's been this whole tension between artificial life and real life, and this has kind of evolved into working with synthetic biology and things like CRISPR, which I'll be talking about. We'll be discussing on the panel tomorrow. A very much earlier work that I did is called The Emergence of Consciousness, and this is from about 2009. I think I started doing this piece, and it stemmed out of my residency at the University of Sussex in the Centre for Computational Neuroscience and Robotics, which at the time was the largest artificial life research group in the world. Very pioneering, because it brought together artists, engineers, and all sorts of people to work collaboratively, mathematicians and philosophers, very central to the core. And Paul Brown, who'll be speaking later, is a professor there as well. And this piece that I made was stemmed out of sitting in on very many philosophical debates with a group that specialised in, they called it the embodied mind, the inactive methodologies research group. And I was very interested in this idea of the body and this idea of embodiment and how you feel, what it feels like to be a robot. There's a famous paper by Thomas Nagel called What It Feels Like to Be a Bat, and he kind of hypothesizes what it would be like to have sonar as an additional sense. In Francisco Varela's writing, he talks about how a robot actually is kind of mindful. Mindfulness, I think it was touched on earlier, is very popular at the moment. But when a robot has these limited senses, it is mindful of just that. It just has this one thought in its head to receive and send this kind of sonar signal or something like that. And I thought, what would it feel like to be a robot? So I worked with all the kind of leading kind of professors there and discussed this issue. And what I ended up doing was taking my sensory input down to as little as possible. So I was, you can see me here being bound in bondage tape. So I couldn't see, I've got earplugs in, and my arms were strapped to my body as well. And I was covered in lidocaine, so I couldn't have any skin input. So I couldn't see anything, couldn't hear anything. I could walk. It was the only way that I could do the performance. And I was given a cane, which I was told was the nearest thing to a sonar that I could have. So the idea was that I would compete against this robot that I built, which is called Mary, after a paper called Epiphenomenal Qualia for the geeks in the room. And it finds the center of a room by using a genetic algorithm evolved control system. And the interesting thing, it'd be great in this room as well, actually, because it's a, sort of got the round end there. It does it in a completely different way to how a human would. So it sends out a sonar signal to the sides of the room and spirals into the center of the room. So the idea was, could I beat the robot to find the center of the room using just this limited sensory input and my own human brain, which is unfortunately I couldn't get rid of at the time. So I couldn't really feel like a robot. But and then I was kind of guided. The only caveat was that my assistant wasn't allowed to let me step on the robot because it took a lot of time to build. So I did this performance and I was wandering around, and at the point where I thought I'd succeeded, I would drop the cane and we would see who kind of won. But the weirdest thing, I mean, I wasn't far off, neither of us were in the end, it turns out, but the weirdest thing was this time when I was inside this shell of having all my sensory input taken away, I was totally mindful of the task of finding the centre of the room. Nothing else mattered. I had no idea that I had 40 people standing around me, watching me in this ridiculous kind of costume. It was completely bizarre. So I think this thing of the body, as Ghislaine was saying, is so significant in this, and how we understand robotics, because this is what I wanted to talk about, and it was this idea of the sensory input. So something that's very important for artificial intelligence is how different it is to us. It's very artificial. We were talking as well earlier about humanoid robots, and this is a lovely humanoid robot that I met at Ars Electronica Festival last year, and it's a sex robot. Obviously, we imagine these are always these kind of sexy-looking blonde or whatever women. This is how it's often portrayed, and here it is, one here. There's an interesting ethical debate around this. One of the things with the My Robot Companion project that I did with Alex was that you don't own your own image, really. You know, we can tweak somebody's appearance. A lot of people look like a lot of other people, so we can take something that looks quite similar to you, tweak it. You don't own that. We can put that on a sex robot and we can sell it to someone. Maybe you could commission it of somebody that dumped you or that wouldn't go out with you. These things are another risk of AI. We talked about care robots earlier, and this is called CareRobot, this robot. It lives in the robot house at Hertfordshire University, where Alex and I are the only people to actually live in that house for 2 weeks. Normally people come in and they research their behaviour in this. It's an actual house populated by robots on a suburban estate near the university that they built. But we lived there, we slept there. It's a smart home as well. So it knows when you've been to the toilet. It knows if you've lifted up the loo seat, and if you haven't put down the toilet seat and things. And it's terrible for men because they never remember to put down the toilet seat. It knows when you're sitting on the sofa. It knows when you've got the TV on. It knows everything. But CareRobot is, you know, the future of this is that, or the reality of this is that it takes 6 PhD students to come in the morning to actually get this thing working, and we weren't allowed to have it physically moving when we did an event in the house where we invited people. They were met at the university and walked to the secret location of the house, because it's got very expensive robots in it, to come and have a kind of meeting with us. But this, we weren't allowed to have it physically using its arm and things like that. It could talk and things when people were in the house, but it's too dangerous. This CareRobot was too dangerous. And when it picks up this bottle, you can hear it crunch. And a lot of the time, the bottle's like that. It doesn't care, so it turns its arm. It's really complicated, this. So the idea of it gently caring is very strange. So we were really interested in this idea of caring, and this is our robot, Harry. We were thinking about what really is caring. It's putting your arm around someone or something like that. The robots don't tend to do that. So we made a robot that would do that. We made Harry put its arm around people, but they didn't expect it. We said to them, would you like to have your photo taken with our robot? And as they were standing there, they were posing, the robot moved and put its arm around them. And these are some of the faces that are captured. I particularly like the one at the top. He works for Microsoft. They all look quite surprised. The only one that looks quite comfortable about it is the guy that works with this robot, which is Casper. And Casper is created by one of our collaborators, a scientist called Kirsten Doughtenhahn at the University of Hertfordshire, and now she's working in another university. And Casper is designed, it kind of looks quite scary to us, I think, and this is touching on this idea of the uncanny valley. But with supervised play with children with autism, it can actually help improve their socialisation. And what it's got ability to kind of move facial muscles. It's actually the skin off one of those resuscitation doll faces that they use, and it's like kind of peeled off, and they put on the robot, and it's got kind of the ability to move muscles and play, and you can touch it and it will say that tickles and things like that. And the children absolutely love it. So they were the ones that pioneered this idea of robots to play with children with autism. And the fact is that this little girl hadn't turned around and made eye contact with anyone really before. And she actually turned around and looked at her carer and laughed after this supervised play session, or during this supervised play session. So this, I think, is one of these huge benefits of this kind of research, is looking at this data and thinking of ways to improve it. And again, with robots and the elderly, this is an event that we did at Fabrica Gallery in Brighton. It was an older people's event for Brighton Digital Festival, where we had lots of people come and meet with the robot, and we talked to them about it. And they said that if they were feeling sad and Harry came and put its arm around them, they thought that that would be incredibly moving. But I wanted to end with something about kind of thoughts around gender and perceptions of what we should research and our own attitudes to what that research is. Because the first question we got asked by some of the older ladies in the audience was, excuse me, I've heard about these sex robots. I mean, is that a thing? Can you tell us about that? So if we're making care robots for the elderly, I don't think we should forget this feature. And I'm not joking here. I think the idea of, we younger people don't want to necessarily think about that sort of thing, but it's a feature we should maybe be putting in and thinking about. And it's interesting that some things are research and some things aren't, but I just wanted to lay that one on the table and think about future life and future sex. And there's just some links to the work, so thank you.
Our next speaker is Lucas Evers. Please give him a warm applause. I'll tell a bit more about you while you maybe install your computer, so we don't have to wait for that. Lucas Evers is head of program at De Waag in Amsterdam. He joined De Waag in April 2007 and is currently leading De Waag's wet lab. He's actively involved in several projects that concern interactions between the arts, sciences, arts and ethics, in the arts and contemporary makers culture. At De Waag he worked on projects such as Trust Me, I'm an Artist. That's a nice title. And that's a project on the ethics of art and science collaboration. And I think therefore it's very appropriate to have him here in this panel. Please go ahead.
Yeah, there he goes. Thank you, Arjon. It's super nice you invited me. And also thank you, Anna, because you thought of me. I don't regard myself as an AI specialist. Does it work like this? Yeah. So I have to say a few things about AI from a different perspective, from the perspective of what we do at Waag, and from a, let's say, more societal perspective, and maybe also from a more artistic perspective, because I think it's a very interesting terrain where we need more artistic appropriation in. AI is seen as something that is going to change a lot, but it's also very diverse. There's also a lot of misunderstandings about what it is. So I think some demystification can happen, and I'm maybe preaching for my own kind here, but I think the arts can do something. For a few of you that don't know so much about what I do where I work, we work in this building. We look at technologies in society and technologies with society, trying to indeed make them more accessible for society, more inclusive for society, and maybe even more fair. We do that in a number of different areas, in care, in education, in internet applications, media applications, and I have set up the wet lab where I know Anna from, and we've collaborated a lot together. We have this place, a very early place where arts and sciences came together. This is a painting of Rembrandt, who is depicting the anatomical lesson of Dr. Tulp. I'm going to go very quickly through this because it's not that important. A few things. We did this project. For those of you who don't know, the Digital City was at the early days of the internet. There were not many websites. It was not graphic. And my director, Marleen Sticker, who is still our director, was one of the initiators of this project, where it really meant democratization of the internet. You could get a free email address and a free tiny bit of 2 megabytes of web space and build your own little corner on this immense website. Later, we also did something like this. I have them in my pocket. It's almost broken. Fairphone is a smartphone that is more fair than other smartphones because it's not using conflict minerals like coltan and cobalt that come from militarized mines where young people work, etc. People are not getting paid well, and they come from clean rooms in China that don't work with people on contract, with minimum wages, etc. This phone does that much better, and every new iteration does. But we also do learn a lot from the arts within our organization. And Arjen already mentioned that. Trust Me, I'm an Artist is one of those works where we see that arts often touch ethical complications in technological development, which we can learn from. And what Anna's idea was that we made into a multiple-year program was this work, Trust Me, I'm an Artist, where artworks were presented by artists in front of an ethics panel that would evaluate the ethical dilemmas, complexities, ambiguities of the work as if it were scientific research. And that was a very interesting way to bring all those ethical complications of technology development to a larger audience. That's also very essential for the other work we do. So the 2 products, let's say, that I previously show, but also interesting for a context of artificial intelligence. So I'm not going to go into the projects we did for Trust Me, I'm an Artist, because that would take us too much time. Quickly, here is another project where robotics played a role. It was also a project I did with Anna, Future Emerging Art and Technologies, where artists were working in a emerging technologies context, where Boredom Research developed those other robots that also have a social difficulty, and that is that they get stressed. Like we have to research underwater pollution conditions, but we get entangled in those nets and pollutions and plastics and so forth. And nobody's thinking about that if robots are maybe going into something that will make them sentient, will make them conscious, and may move them into a situation where they start to become like humans or other organisms. So another interesting complication is, for me, when AI is not confined to a computer, but is able to get into your head. This is a work by Guy Benary of Symbiotica, who made a synthesizer using his own brain cells, his own neurons that he put on a biochip, and created a system of that can be seen as a synthesizer a musician can interact with. If you do that with your own brain, and you have indeed algorithms that can influence your behavior there, I think there it becomes ethically very complex. And also going back to the questions that were asked to me, should we be afraid of AI? Is it going to take us over or not? I think these kind of situations may be really difficult. So also, because my understanding of technology is very much in biotech, this is very interesting work. I also wanted to quickly ask some attention for. It's a work by the Tissue Culture and Art Project of Arjon Dunnewind and Dumitriu. Artificial intelligence is often seen as something that is happening in computers. But in laboratories, there's a lot of synthetic new organisms made that, to a certain extent, if you compare them with what we call now AI, are also intelligent. And they are not part of a natural biodiversity. They comprise of a synthetic biodiversity. And I think it's interesting to see where the biological and the digital are going to meet in some future. So coming back quickly to that format of Trust Me, I'm an Algorithm, or Trust Me, I'm an Artist, we at Vaag Society were going to intensify working with AI because we think artists can really bring something to the discussion of where we see difficulties with applications of AI in society, where it's about exclusion, where it's about non-openness, etc. So we are going to work with artists that are going to put the algorithm on trial, having the algorithms being evaluated by ethicists. And even what if you turn that around? If you would say it's not human agents as ethicists at the panel that are going to evaluate whether something is right or wrong or what is the matter with it, but what if it be an algorithm? Developing a lot of the projects with artificial intelligence at Vaag Society. We also understand that a lot of the AI that we see is based on data sets that are not accessible by citizens. So it's not accessible by society. It happens in silos of big corporations like IBM, like Microsoft, like Google, and so forth and so forth. So with the Larbit sisters that have done a project that is about understanding the value you create when you are clicking on all the features on Facebook. For Facebook, it is saying that you should reclaim that value, that monetary value, because you're giving it for free, which tells me that we are in a high need of creating citizen-accessible data sets to create new sorts of AI on. And I think an artistic practice can help there also very much. So going back to the questions that were asked to me, can AIs make art? Yeah, I think it can, and I don't see any problem there. The limitations of machine learning and genetic algorithms, I think it's probably fossil fuels. I think if we don't have enough electricity to power big computational plants, supercomputers sometimes need the electricity of a whole power plant. Part of a whole city can be running off. I think that can be critical. I think control and legislation for AI can be done with the law set we have now. We simply should be very responsible with it. And if you're discussing whether AI should be given rights, I think we should also have a very good discussion about the rights that we should give other organisms. And I don't think it's an existential threat to humanity, while we may get a bit confused by it. Lastly, I would love to end with a very short video of an AI work that I think is very interesting, because it also says, it relates to the issues of exclusion that exist around what AI can do, because it's always looking for normalcy, the most counted values. It's a work already a few years old. It's now on show in Berlin. It's a work called the Turing Normalization Machine by Michon Zeraviv. And yeah, let's see how that goes.
In the 1930s, British mathematician Alan Turing studied normal numbers, and during World War II, he cracked the Nazi Enigma code, and then laid the foundations for computing and artificial intelligence. In the 1950s, he was convicted of homosexuality and was chemically castrated. And in June 7, 1954, depressed by the anti-homosexuality medical treatment, and alienated by the society who deemed him abnormal, Alan Turing ate a cyanide-laced apple. In the following decades, many of Turing's ideas have materialized through the digital revolution, while many of them are still being researched. Inspired by Turing's life and research, we seek to finally crack the greatest enigma of all. Who is normal? The Turing Normalizing Machine is an experiment in machine learning using social pattern recognition that documents, analyzes, and charts an aggregated image of the normal human being. Participants are presented with videos of 4 different people, and then helped teach the machine by selecting the most normal of the 4. The person selected is examined by the machine and is added to its algorithmically constructed image of normalcy. The kind participant's video is then added as a new entry on the database. As the database grows, the Turing Normalizing Machine develops a more intricate model of normal appearance, and moves us closer to our research goal. It is needless to say that the results of this research can be transformative to a wide range of fields and applications. From advertising to politics. From human resources to online dating. From healthcare to security. We're already seeing some exciting results, but the machine only knows the communities it is exposed to and can only tell between the people it already met. The Turing Normalizing Machine is eager to learn from a wider and more diverse audience, and we would love to collaborate with you and the people around you in making it happen. Thank you.
Thank you.
So we're now ready for our third guest, Jan Broersen. He's connected to the Intelligence Systems Group of the Utrecht University and the Department of Information and Computing Science Faculty of Science. In 2014, he was awarded an ERC Consolidated grant of 1.9 million euros. I guess you can do a lot with that. And the project that you started with that is almost about to finish. Yes. You'll present the results in a few weeks, as I understand it. The idea of this grant and the project was to develop the theoretical groundwork for an automated prototype to check responsibility, liability, and risk in situations where tasks are delegated to intelligent systems. I'm very much looking forward to your presentation. Please go ahead.
Okay, thank you, Arjon. So my presentation will be a little bit different. I don't think I have any pictures or any videos in here, and as Arjon says, so I know a lot about the technicalities behind artificial intelligence. Let me show you first my short CV. So I studied mathematics in Delft University. Then I was a high school teacher for 3 years, so I teach mathematics to high school children. After that I did a PhD in computer science in Amsterdam. And then I worked in artificial intelligence from, let's say, from the computer science perspective for 13 years. And that's what Arjon actually mentioned in his introduction. But I'm no longer working there. I'm no longer working in computer science. I'm now working in philosophy. And that is mainly indeed because of this big project, this big European project that I got. And this project has the title Responsible Intelligent Systems. So in that project what I try to do is there to endow artificial intelligence with a sense of responsibility. That's the big issue. Nowadays everybody is talking about it, but this was a project that I already proposed 5 years ago. And I got a lot of money for that, and in the last 5 years I studied that. And mainly from, let's say, my perspective as being a logician, being a mathematician, being a computer scientist, but also being partly a philosopher. So I made the move to philosophy. I'm now a professor in philosophy. And well, what I have to do there is that I'm studying logical methods for artificial intelligence. And what I'm interested in is artificial intelligence, logic, politics, blockchain, ethics, music, film, and a lot more. So that is, let's say, so that you know what my background is. So I was very much interested in the questions that were being put forward here when this thing was advertised. So these are the 5 questions. Also, the previous speaker alluded to them very briefly. And I like to think about these kind of questions very much, also in the context of my project. In the project I'm doing much more technical stuff, but philosophically these are of course very interesting questions, and I do also have some answers. Those are my answers. So I thought when preparing this very short talk, I should just give the answers to these questions that as I think they are right, and they are, at some points they are very different from the previous speaker, so that is good for the discussion and for the panel discussion that we will have afterwards. So what are my answers here? Let's go to the, already here we have a difference. Can AIs make art? I would say not really. I will go a little bit deeper into that after that. Let me first just give me the answers to all the questions, and then we can discuss why I think that this is the case. So I think actually that computers cannot make art in the same way that we humans can do, which sounds a little bit provocative maybe in this context, but I would also say it's good news. Okay. So what are the limitations of machine learning and genetic algorithms? So I know a lot about that. So I know about artificial intelligence. I'm from that world. And in my opinion, there's many limitations. So it's not only the fossil fuels or the energy that you can use to make these machine learning techniques work harder or work longer or work better or perform on much more data. No, there's a lot of limitations to these algorithms, and I will also go a little bit deeper into that. So, and then the other questions, I will not go deep into that. I will just give my answer. So this is the same answer roughly as the previous speakers gave. How can we control or legislate artificial intelligence? Well, I would say that is just a matter of clever programming and coming up with the right rules. That's how you do it. That's how we do it with humans. That's how we do it with AI also, how we should do it with artificial intelligence also. And then should AIs be given rights? And there I would say maybe. Why do I say maybe? Well, rights, that is, it depends a little bit on what you mean. Do you mean rights in the legal sense or in the moral sense? And I interpret this question here as rights in the legal sense. So what kind of legislation would you put forward? And in this legislation, should we have this construct, that's how I see it, that you give an artificial intelligence legal personhood? And that is just a construct that we have to regulate things. Companies have legal personhood or groups, and we can just do that because that is by way of regulating artificial intelligence. But actually, the European Union already did that. They put forward a proposal to say that, of course, the devil is there in the details, because what kind of machines would you give rights and what kinds of machines would you not give rights? So there the question, I would say, it's maybe. So as a construct, that could be very useful to give AI rights. But let's say from the moral, philosophical perspective, they would never, and then we come to the final question that I have an answer to. I think they will never rise up to our level. So in that sense, they do not deserve rights, I would say. And that's from the moral perspective not, but from the legal perspective, yes. Are AIs an existential threat to humanity? I would say no, not at all. And that's very interesting because I work in the area. I've worked in artificial intelligence for 13 years. And I've talked to Nick Bostrom, who is, of course, proposing this idea of superintelligence, and that intelligence will overtake us because at a certain point they will invent ways of reproducing themselves and making themselves smarter, etc. And then we have this exponential growth. And maybe you know all this these arguments that he has, but I think that is just nonsense, actually. So that's my opinion. So if we maybe in the discussion we can talk about it a little bit more. But I promised to go a little bit deeper into these first two answers, so that's what I will do. So can AIs make art? I would say no, and that is also. That is mainly based on my experience with this. So I have had many students who had the idea to use artificial intelligence to create new pieces of music. So then they come to me, and then I like that idea, the idea that you can produce new compositions, new music compositions using computers, and then maybe have the same quality that we humans can produce. So I like that idea, so I always say to the students, yes, let's try to do it. And always I'm a little bit disappointed at the end. Because in the end, and there's all kinds of connections. So if you think about a computer composing a piece of music, and you do it from the AI perspective that I come from, the technical perspective, there's only one way to do it. It's very hard to imagine another way to do it than just, okay, we make a search space, we put in some knowledge about music, some harmony, knowledge about harmony, about tones, levels, about pitch, etc., and structures, what's the structure of music, and then in the end, okay, it needs to be creative also, so it needs to come up with its own, so it needs knowledge to create something. But in the end, so where is the creativity? Where is that hidden? And in the end, it's always, okay, we put in a random generator, and then the random generator produces some things. And then, okay, we have an evaluation function, and we evaluate what comes out, if it looks a little bit like what we already have, and then we have a piece of music. And I don't see any other way of doing that. There is no principled other way than doing that. And always what comes out is disappointing to me. So then you think, okay, but if that is impossible for a machine just to come up with a very interesting piece of music, why can we do it then? Well, I'm also a little bit in music, and then, of course, randomness also, when you are composing a piece of music or something like that, it plays a huge role. So something unexpected happens, and then you think, that's interesting. And this judgment phase, so when something unexpected happens, and then you judge, that is interesting, that is where the creativity is, I would say. Because that is where you put in your human judgment, your human interpretation of the thing, and at that point, you change the whole thing, you steer it in a certain direction, and you come to an outcome that is interesting to somebody. So that is my opinion on it. So I think as long as computers cannot do that part of the creative process, the interpretation thing and the judgment thing, of course we have all kinds of derivatives of judgments in computers. So you can make an evaluation function, but you always have to make it yourself. As a computer scientist, you say, okay, this kind of features might be interesting. So then you do it again, then you are putting it in again, and then it is not the machine that is being creative. No, it's always, so there is also a paradox in there. So if you want to create something that is original, that if you want to create something that does something original, you're always programming it in, and then because you programmed it in, it's no longer original because it's you that programmed it in. And so there is this paradox. Well, I'm a little bit skeptic here, and if you look at, for instance, there is this machine making Bach compositions, and there is this machine making Beatles compositions. Maybe you know that. I'm a Beatle fan. And then you listen to what it produces, and you say, yes, that sounds like a Beatles song, but it is not a good Beatles song. It's not an original Beatles song, or it just does not have it. That's my opinion. So that's my opinion on can AIs make art? I would say no. Well, that is of course different from saying that we can, of course we can use machines to make interesting art. But then it is the human using the machine to make interesting art. That's something different. So the question that I'm addressing here is whether the machine itself can do it. That I don't think so. But for instance, what the first speaker said, that is of course very interesting, but especially because the human is still interacting with the machines. That is artistically very interesting, but the machine itself cannot do it. That would be my opinion. Okay, so do I still have some time? No, 1 minute. Okay. So what are the limitations of machine learning and genetic algorithms? So here I listed a few. The kind of AI that we have now, the kind of deep learning techniques, etc., the kind of AI that Google is actually putting forward, it cannot do reasoning. It cannot do consistency checks. Well, I can tell you a lot about it, but I don't have the time anymore. It cannot recognize causal relations. So if we think about the world, we know that this thing causes that thing. And on the basis of that, we make all kinds of judgments about the world, etc. That's what those deep learning techniques have very much problems with. There is a paper about multiplication and math. That's the kind of things that we can do, and actually I am a mathematician, so I can do that kind of thing. Deep learning techniques cannot do that at all. So those are limitations. Rotation objects into, well, okay, there's a lot of many more things, but since I'm out of time, I want to I do have a picture. So in the next slide, there is this picture. Here you see a big limitation of these, let's say, artificial neural networks. So artificial neural networks, they are mainly used for a big application area is classification. And so classification, the neural network is fed with all kinds of examples, and then after it has learned how to classify certain examples, you can give it a picture like this, and then it will classify it as a bus. But in a recent paper by some Japanese people, and there is a lot of follow-up research already being done, it was shown that if you superimpose this picture and this picture with a lot of noise, and you feed it to the same network, then suddenly the network sees an ostrich here, which is something, of course, for a human that would never happen. For a human it would never, this is still a bus, and this is a bus. And if you add some noise to it, and then suddenly the network classifies it as an ostrich, then something has gone wrong. That kind of mistakes we never make. And it is even more extreme than this. And so this is called the 1 pixel problem now. They showed that given a class of classifiers based on deep learning techniques and given a class of tasks that these classifiers have to classify, it's usually possible to change only 1 pixel in the picture and then fool the classifying system into classifying it as a completely different category. So here this is definitely not changing 1 pixel. This is adding a lot of noise to it, where for the human eye it doesn't make a difference, but for the machine it does. But it is actually true that for a large class of examples you only have to change 1 pixel, and then you have these kind of phenomena. So that is, of course, that shows something very deep about these modern classifying systems, these deep learning techniques. The only thing they do is just take all these pixels as input, run it through a neural network, and then, because it is trained, it comes with a certain output. But if there is going one thing wrong, the whole network classifies it as something completely different. You can always find a certain thing that you can change here such that the classifier goes wrong. That will never happen with a human being. That's simply, you cannot change one pixel here and then make us believe that this is an ostrich. That's just impossible. So this points to certain limits here. Maybe for some people this comes as not good news, because many people think, okay, AI is capable of so indeed, the successes are enormous. But these, here you see an example of something that we humans are way, way better in, and actually it's hard to believe that a computer will actually, especially a deep learning technique, will ever overcome this kind of problems. Okay, thank you.
Thank you, Jan. And I would now like to invite Jan to also stay on stage and Anna and Lucas to come on stage. Choose your favorite seat. To start with, I like the fact that we're all sitting in front of this label saying antisocial swarm bots. It could be us. Jan and Lucas, you both responded to the 4 questions that were kind of on the table for this panel. And maybe, Anna, you could also just briefly respond so we know.
Questions?
No,
I can do it.
Here are the questions for you.
Can AIs make art? I'd say not yet, because we don't know what improvements would be made on that.
Maybe we start with that one then.
Okay.
Because Lucas was clearly the one saying yes. And maybe you would like to nuance that a little bit, because the 2 other people here in the panel are not so positive on that one.
I know there is examples out there, and I don't know them really specifically, where people were not able to understand the difference between the computer-made art and the non-computer-made art. Also your argumentation, I thought was not too strong, because judgment is also something random. It's simply better than computers can do now, I would almost say, if I understand you well. And I wouldn't see a problem if an artificial being could make art.
Well, maybe it's not a problem. The question is only, can it do? And I think this argument where people are asked to compare a computer-generated work of art with a real work of art kind of fails, because it always compares it, something that is already there. And I think the quality of art is that it surprises us with something new. So if people cannot tell the difference between a work of art and a computer-generated work of art, that doesn't solve the problem, because it's showing just how much a computer can do something that has already been done.
Yeah, true. I agree there. But it also shows our kind of judgment can be beside the point there. Mm-hmm. And I think I agree with the 2 other speakers here that the question doesn't say much about the quality of the art there. And I think, how originality is constructed, or how meaningfulness is coming about. We have no computers to replicate that. And, well, I don't know whether we should be happy about that it doesn't. Something meaningful is something meaningful. If that comes from a computer, I could be okay with that if it tells me something interesting that I can learn from, that I can have an emotion about. Yeah.
I think one of the issues is this idea of, can they be creative? Because we haven't really got a proper definition of creativity as yet. I mean, Professor Margaret Bowden wrote a very well-known text on this creativity, myths and mechanisms, where she talks about different kinds. And then computer scientists have been trying to convert her theories into programs and algorithms themselves. But it's obviously a massive struggle to kind of do that. And I think Paul Brown will probably talk about it in his keynote, because he did a collaboration with Margaret Bowden where they wanted to use, and this is a very long time ago, a genetic algorithm to make a creative robot. The project kind of stalled in that they couldn't really settle on a definition for creativity in order to decide whether it was. And it was again one of these quite large funded projects.
Before we continue, I would also like to point out that whoever feels like asking a question or contributing to the discussion, raise your hand, and there's already one. But first, Jan has something to say.
Yeah, maybe a reaction to what you were saying. So maybe, of course, there can be very interesting examples of artworks that are being produced in some sense by a computer. Of course, you'll always have to ask, in what sense was it actually produced by a computer? And does it make all these interesting artworks all the time, or is it just made it a lot of things, and did we select something that we thought is interesting, and then the comparison is not really...
Doesn't that really just happen with art anyway? That artists are making bad stuff all the time, and then sometimes we select, or curators, like these here, would select something from us that then is taken up in a different way. You could argue.
Yeah, no, of course, and that's also interesting to do. And about this judgment part, I think it's about artistic judgment. That is something that I'm skeptical about, whether it is actually possible to somehow program that in.
But I don't want to be boring or cynical, but what is artistic judgment?
Okay, right.
It's the same as my lack of creativity definition.
And I think the question sounds nice and provocative, but at the same time, it's like maybe a bit like Nick Bostrom saying that we should be afraid of singularity. I'm not afraid of that.
No, me neither. So there we agree.
You know, he's funded by insurance companies.
Sorry?
He's funded by insurance companies, I found out.
Really?
Yeah, so this is why his work's all focused on this existential threats. It's insurance speak.
Okay. I didn't know that.
That's what I was told.
Okay.
Maybe now we're also maybe coming to the last question. We could jump to that. Are AIs an existential threat to humanity? And you're saying you're not afraid of the singularity, which is, to me, feels like answering this question with a no. At the same time, I mean, there's prominent people, Stephen Hawking, Elon Musk, that do warn for what AI could lead to. Maybe we should nuance that, what AI leads to if applied in a wrong way. I'm very curious what your opinion is on the way they see the threats and why you think we should not be worried so much about that.
Is that a question to me?
To all of you.
I can give an answer, yeah. So I just don't believe that the kind of machines and the kind of artificial intelligence that we have now is good enough somehow to match our capacities. So in that sense, it's also impossible that it will overshadow us, because Turing was already in the picture. So these are Turing machines. They are not even Turing machines. So now it's becoming a little bit technical. But if you look at the kind of machinery that is behind artificial intelligence, it's extremely simple. It is, and I think that, for instance, people like Bill Gates, and so they think that what's running in here is the same kind of machine that is there on the table, that there is no principal difference between the two. And I think there is a principal difference there. And so these are too simple machines to rise up to the level that we have already reached. And that's just because they are the kind of machines that are too simple. We need
when
something
Turing built his
completely
computer,
different.
there was a full room. Now it's 20 by 30 centimeter.
Yeah, that's all of this, more of the same.
What does it say about how fast these developments will go and how long? Because you're saying not yet.
I think these machines will never rise up to this level. How much, how fast we we make the processors, how much memory we give them. It's just that the architecture is not up to it. So I think, so when people think about how we function, we have that as a model. And that's why everybody thinks that we are functioning in the same way. But why do we think that? That is just an assumption, because that is that's typically what computer scientists, I've been a computer scientist for 13 years, they look at the world as if it is a Turing machine, as if it is the thing that goes from one state to the other state. There's a little transition there, and we can all lay out this in beautiful mathematical pictures, and that's what it is. But I think the world is much more complex than that. So if you talk to a physicist, he doesn't look at the world as if it is a Turing machine, as if it is a computer. So it's much more complicated. You have quantum phenomena, you have things that are completely not yet understood. And how can you then think that what's in our head is just that simple machine? Maybe it's much more complex.
Well, so maybe the threat is that we make ourselves dependent on this technology.
Right.
Like a lot of processes that we normally would do ourselves are being automated. So that's why I'm asking,
So
maybe
we've
it's
always
not the
done that.
technology itself, but the way it's applied.
Yeah, but where we make ourselves dependent on technology is about us and not about the technology. So it's about rules and about attributing rights and obligations to machines. May they become so capacitated that they are going to be a threat to us, which is what we do with self-driving cars. However, they are stupid. But you don't have to give them rights. You should give them rules how to drive or not. So those threats are. If you think about that human should not impose something on another human, and in fact also on other organisms that the other doesn't want, then you can make that into a rule system that is moral and ethical, and that the same counts for how you can arrange that with technology, I think. But I think it's a better discussion than also to think about the Party of the Animals we have in the Netherlands, the Partij voor de Dieren. Should we have a party for computational systems?
Start it. I wanted to sort of say, 'cause, I mean, we're talking about this sort of traditional computer architecture, but who's to say that it will continue to be like that? And you brought up the idea of the biological, and we had a lot in the previous panel about neural interfaces, and you talked about Guy Bernari's work. I mean, a lot of people are working on these kind of fusions between neurons and silicon. So, I mean, that could be a possibility as well for these things. It could still be a kind of artificial intelligence at that point. So I think sometimes, so this question, can AIs make art? It's sort of, can they currently make art, or can they make art, like possibly at all? Right. And I think the answer's different. That's why I said maybe.
Yeah, that's a very good point. So the point is, of course, what is AI? What do we consider to be AI? And usually people, if you read articles nowadays in the newspapers, they mean those machines. But if you broaden, of course, the label AI to, well, then we ourselves are maybe in a sense AI.
I mean, originally robots, when it was the term was kind of first defined, are biological entities. It's in the book with the play Rossum's Universal Robots, RUR, by Carol Chapek. They're biological entities that basically don't have a soul, and they are an existential threat to humanity. They kind of kill off humanity, but then become humanity. Sorry, spoilers.
Tonight, in tonight's keynote, there will be a lot more on this question, if AIs can make... Yeah, we have questions from the floor, starting with Alex.
Well, I would like to say that I think the question is missing something, because it's analogous to saying, can a paintbrush make art? And by itself, of course not, it would just sit there. If an artist creates an AI to make art, I would say that it's making art, but it's by the instruction of the artist. It's not just going to sit there and plop out art pieces, because it was never trained to do that. So somebody has to train it to have a thing, you know, a purpose.
Who is training the artist?
Well, that's, you know.
What we need is a computer that one day just says, I'm not going to do this processing anymore, I'm going to make these things, and then we'll know that we've solved these things.
Yeah, there's a great artwork, I haven't seen it myself, but by Pierre Huige in a gallery currently in London. I come to that, but what he did there is he tries to let an AI develop imagination. He uses a chip in someone's brain to record imagination or images in the brain, and that is recorded and fed to an AI, and that AI is trying to make images as we see them.
I've seen the work, not completely true.
Okay, but please correct me.
They use a database with already given pictures.
There's the microphone for you.
So the activity in his brain activates data from a database. So, I mean, yeah, that's different.
Yeah. Yeah.
So
Thank you for
the
that.
story is nice. The story is nicer than the work.
Okay, but he's trying to go at that, and he could potentially, by feeding the AI more images that are coming from a human brain, I would say. I would be interesting also to ask Jan, because I was saying something about data sets. And about a certain need for societal data sets, but are we past the point that AI actually doesn't need that much data anymore because it is already computing all new things itself, in part?
No, I wouldn't say that we are not yet past. If I understand you correctly, you're worried about the fact that we actually involuntarily give our data to big companies like Facebook, that our data is implicitly somehow already stored in the internet or something
No,
like that?
what I mean is that if an AI could develop its own rules on a set of 100 data of whatever, then you don't have to give it more than that 100 data.
Well, so the current AI algorithms that work with data, the data-driven approach to artificial intelligence, just needs enormous amounts of data. So, for instance, in these self-driving cars, well, you probably know all that. But what I sense there is that you have a worry that at a certain point the data is no longer necessary, and that the AI will find other ways to become smarter because it finds other ways without the data or something. So that sounds a little bit like the singularity kind of situation.
Yeah.
Right. I don't believe in that.
Okay.
But that is also just because, well, partly just because of my experience with those systems. I've seen many of those systems, and so we always have the opposite problem. That we start out, for instance, with the student, we work on something, maybe usually in a virtual environment, in a game environment or something like that, and we want the game character to behave in a certain way. We use a neural network or for that. And then it is never like you describe, that it's unexpectedly does more things than we want. It's always that we aim for certain behavior and we never reach it. It's always so maybe also my judgment is colored by that, all those experience that I have with those systems. But it also shows that how you work with that type of AI. You yourself. So this is there's a little bit of technical term, but so this is the kind of supervised forms of machine learning. So you, as a human, you are the supervisor. You say, I want this piece of software to behave in a certain way, and I tell it how to behave by giving it examples, and then at a certain point, it will behave a little bit in that way because it is going to mimic all those examples that I gave it. But it is never doing something more than just interpolating or extrapolating all the examples that it is given And also, if you look at it, what is happening in that kind of algorithms, that's exactly what it's doing. It's doing a kind of induction on all the information that it has. And it extrapolates and interpolates, and that's what it does. But it will never reach. So that it's very hard to imagine that such kind of a system like that will then suddenly no longer need the data to improve itself.
Yeah.
Just that step is very hard to imagine.
There's a question there.
Anna,
Could you wait for the microphone?
can you speculate a bit for us about possible fantasies when we go in the future and what you told about systems that merge? Would you like to do that for me, please?
Well, I mean, I was thinking about, because now, tomorrow's panel will be more related to this in terms of synthetic biology. In the film that we had last night that Arjon programmed, this Genesis 2.0 film, there was a lot about synthetic biology in that and the possibilities to program at a cellular level. Also, we have possibilities for 3D printing and tissue engineering. Some people say, no, we'll never get that far with 3D printing, bioprinting and things. I actually think that we will. There's enough people really trying to do it. If there's enough people working on things, they do tend to happen at some point. And it might seem really far-fetched and something keeps going wrong now. For years and years and years, they thought we couldn't culture human cells at all. And then it became possible for lots of different types of human cells to be cultured. They all got contaminated, but that's another story. But I think we just need these kind of steps forward to happen. So I think it's entirely possible that we would be able to combine digital life and synthetic life. You could create programmed cells and things like that. And then from that, it steps forward. It's all these technologies could come together. And I mean, in the panel that you were on, there was all this talk about these kind of neural interfaces and the cells coming together. Ghislaine, I think, showed a slide of Kevin Warwick, who was the, Professor Cyborg, the world's first cyborg, and he had a neural interface in his arm, which was very dangerous, kind of at the time. And his team and other teams at Georgia Tech and stuff, we've been working with kind of robots that are driven by kind of rat neurons and things like that. So you can run electrical charges actually through the neurons as a kind of computational wetware kind of brain for a robot too. So there are things out there, and there are all these people working on it. And the fact of the matter is, in terms of neuroscience as well, when I was first working at Sussex, the scientists there would say, well, we can get a few brain cells kind of squidged onto a kind of microchip, but this produces so much data, I need 5 supercomputers to do it. Tomorrow we've got Freek Holbeek coming, and the research that he's been doing with the University of Hertfordshire as well, he's at Utrecht University, they don't need that anymore. You can process this stuff much more easily and much more rapidly. So they're learning in just a few years massive amounts about how the brain works, and using these techniques, these limited artificial intelligence techniques and data mining techniques to actually understand what's happening there. So I'm a bit positive towards that side, and I think that a lot weirder things that we can even think about will probably happen.
Yeah, there's a question there.
So I'm going to go back a bit, actually. Thanks for that, though, Anna. I agree. It was good to get that input. Yes, so I just wanted to go back to the whole thing of actually looking at AI making art in its own right. Yeah, the first question that you've had. And actually to discuss a little bit more about whether, from my input earlier, as you know, whether that just means we just need this conversation to happen between humans and AIs, that algorithms are made by humans, they've got their rules set by humans. And I was thinking back to things like generative music, the Brian Eno Koan system, which I worked with in the mid-90s, which has now gone past hardware and is now software like Bloom, which is the app. these are systems which allow others to make art. So your input when you said, but who trains the artist? Yeah, really kind of clicked in my head, and I thought, we don't need to train artists. It's actually potentially that the artist that makes these generative or AI systems actually then allows a democratization of what an artist is. And we're seeing that in a lot of apps, in a lot of creative places. And actually then to link that back to what you were saying, Lucas, about the Trust Me, I'm an Algorithm project. Because I found it fascinating, replacing a human ethics panel with an algorithm, which is then going to take judgments ethically on other algorithms. But isn't that just the same as doing it with humans? Because they're made by humans anyway. And are we not, therefore, I'm just going to make a case now for the physical body and us still to be involved in all this. I see it as a conversation.
I think that's an essential problem here, because we're talking about artificial intelligence, and what is it then artificial and what is intelligence? If you understand that we could be more complex algorithms than we can replicate, I would say. So the data sets and the rules always remain coming from humans. In such a case. At the same time, having organized quite a lot of those sessions with Anna, there are very long conversations going on then. It would be interesting. Well, the artificial intelligence in real life, in a commercial context, are about efficiency. So you could do those discussions very quickly. They could probably last for maybe 1.2 seconds. Then you have it all done. But it would be interesting to understand whether there are, because they can compute much quicker and much more at the same time, that will lead to new arguments. Maybe. Arguments that you would normally need a lot of editions of Trust Me, I'm an Artist for. I think that would be an interesting experiment. But also for me, I'm positive about what we can do with AI as long as we act with it responsively. And in that sense, and maybe that is going a bit away from the case, I think we also need to discuss AI in this context of responsibility a lot, because there's so incredibly much hype around it in society that it's going to solve this and this and this and this. And there is no good discussion about it, what it is, because it's so much now. And I would really love such an experiment like Trust Me, I'm an Algorithm, to demystify the whole terrain and to make a difference between where we can really use it. And I've seen people in medical situations making algorithms to assess whether someone being brought away from the intensive care would come back in 3 days or in 5 days. I think that's super. But there's also...
I think Anna wants to respond.
Sorry.
Also, demystification is something I'd like to respond to, but Anna, maybe...
Well, I just want to say briefly about ethics. I aesthetically, I love the idea of this judging AI algorithm bot that just could go through every court case in the world, go yes, no, yes, no, yes, no, like some kind of horrible nightmare. That's kind of gorgeous to me because I'm quite a weird person, and horrific, but at the same time. But the thing with ethics is that that ethics arises when there are at least two conflicting views and no clear answer. So that's very hard for like logic to decide on, which I guess might be an issue, but I still love the idea of it, and I think we should probably try. to build
Yeah,
it.
many
Just as an
people-
artwork at the very least.
Many people have loved the idea, indeed, of having judges being replaced by artificial intelligence or something like that, because, well, the idea is, so what they do is just like, they go to law books and they are full of rules, and to apply them very consistently and thoroughly, etc. Maybe an AI can do that much better. So, of course, that's a good argument in favor of doing that kind of thing. But I think there's also arguments against it. I would think exactly what you say. So there are border cases. There are cases where it's not very clear how the rules should be interpreted, whether the rule applies, what the rule actually says.
I think that's in the
If
third
you-
appeal.
if you
You'd have
combine
to
that
deal
with-
with that.
If you combine that with the idea of a self-driving car, it would have to decide in moments of danger. I mean, this is a classical example. Am I going to run over 3 young kids or 3? There, like all these rules that normally a judge would take, you could say, okay, that should be the essence of a self-driving car, that it would take the decision that a judge would have taken if he would have judged the situation in hindsight. So, do you think, well, that kind of argues in favor of using such technology if we want, for instance, to use a self-driving car. Otherwise, it could never take the decisions that we as a society find the most ethical decision.
Well, so the first thing to say is that these kind of problems will become real, and if they are not already real to a certain extent. So these kind of thing, of course, people already died from car accidents with self-driving cars. So these problems are real. These issues will have to be decided on somehow. So the people making the self-driving cars, they have to do something. So, but they will take a practical approach. They will build in some rules for making these kind of decisions, as you also suggested, and that I think that is good. And those rules might even perform better in those situations than humans would. I mean, typically, if you are in such a, well, probably we have never been in such a situation, but you can imagine yourself being in such a situation, and whatever you actually do, probably you're thinking very fast, or you're reacting just reactively or instantaneously, and whatever choice you make, before the judge, you will always say, well, it was a split-second decision, and I didn't sleep that well, or I mean, there's so many excuses. But all these excuses, they will not be granted to, let's say, Tesla or Google making the self-driving cars, because then it's the car, and then everybody will think, okay, but you have programmed it, and you have to make that decision. So they will be very practical about it. They will build in some rules, some decision rules. That would be one approach. So the MIT has this very moral machine project where they just presented people with all kinds of different situations related to this, and then you can say, oh, I would do this, I would do that. So in principle, you could then run a machine learning algorithm on that, and that machine learning algorithm produces then decisions that you can build in those cars. And I think that would be a very sensible approach, and the cars will not perform worse than people in those situations. So from a societal perspective, that would be all okay, I think. But I still think that that car is then not making an ethical decision. It's just we program it. So the car is not like a judge understanding what it is to be a little child. Well, to a certain extent, we had this paper on what it is to be a bat. So, but in a sense, we feel, we put in our emotions, we can, what we can do as if we were those persons, and then think, well, I would not like to be hit by that car or something like that. That kind of capacity those machines do not have. They will purely react on all the examples, on the let's say the interpolation of all the examples that we gave it, or on the explicit rules that we gave it. But it will not make the judgment in the same way that we make the judgments. So that's what will happen, I think. The solution is just practical, and there will be. Those machines will be there. They will make the decisions. At a certain point, we will accept them. But we should not make the mistake that those machines are then moral machines or are in any way comparable to what we are. That's my...
There's a question back there. If you wait for the microphone. Yeah.
Yeah, so thank you for your interesting presentation. I would like to talk about the matter of ethics in relation to what you respond to the threat of humanity for you, Sir Evers. You said that humanity, so IA is more a threat, is less a threat for humanity than humanity itself. And you talk also about the fact that IA is based on normalized normalization. And so I was wondering, in what extent can we see the IA has a threat in the matter of sexism and racism, for example? I was thinking through the example of the chatbot of Microsoft, which was launched, I think it's 2016, and who started nourished by a lot of sexist and racist tweets from other users to be also reacting as them. So yes, I was asking you your thoughts about that.
Oh yeah, I don't know that much how that bot was designed in a way. I don't know whether it's beside the point, but I did a little presentation with two artists about image recognition for the police force in the Netherlands. What the police force in the Netherlands does is protect the citizen at first. So there's no profiling, they say. In China, it's the other way around. They say, if you have not done anything wrong, then we can follow you wherever you are. So every possible system is connected there, which makes that everybody becomes has a record of running a red light, not giving, an enormous heap. So I think it depends on how you train and design the algorithm there, and with which biases it happens. So. But again, that is the question of how we design it and how we apply rules on which it makes it averages. And so far, it's still artificial and it's not intelligent in a way. So I hope that is an answer to your question there. Yeah, maybe Anna or Jan can add something here, but I'm worried about that kind of monitoring of citizens by so-called intelligent systems.
Yeah, maybe I can also give a short answer. So you're talking about this Thai bot, I think it was called, the Microsoft Thai bot, and it was so it was a chat bot. It was online, and then of course people thought it was funny to feed it with all kind of so that's the kind of AI systems that we have. You feed it with examples, and then it's going to behave like the examples, so you can manipulate it. So this is the whole problem of bias in AI. And that's exactly, so this example that I gave with this classification of the bus and the ostrich is in a sense the same thing. So it doesn't really understand. The only thing it does is reproduce what it gets and takes the average of what it gets, and that's what it does, but it doesn't understand anything. So then you can manipulate it. You can, everywhere where there is rules involved or where there is an algorithm involved and you know a little bit about how the rule or the algorithm functions, And they run on the machines. Once you know it, you can manipulate it as a human being, because then you can just play the system. Let's say that's what. Well, I've been a teacher, as I said. I know. So if you want to control the children in your class, you also come forward with rules. So as soon as you give rules, they're going to play the rules. They're going to discuss it, and they will. And that's the same thing with those systems. As soon as you know how they function, then you can play them. And that's what happens there. And that's also what everybody is afraid of in artificial intelligence, that all those biases that are... So the people making the algorithms, they implicitly put in a bias. The training data that are used to train deep learning networks, well, they contain a certain bias, because you feed them with certain examples and you do not feed them with other examples. So the difference between the two is your bias towards what you think how the behavior will be. But the machine itself doesn't distinguish anything. It does not know why one example would be better than the other, like we would. So there's a difference there.
Jan, thanks for your question. I think we're very short on time. If there's one very urgent question that can be short.
No, I just wanted to add something. I think people like to communicate.
Could you wait for the microphone? There it is.
People like to communicate so eagerly that they don't care if it's a machine. So they project, or that's what I found out with the bot I worked with. So they project so much of their own, what they are, if they are seeking for a friend or whatever they are looking for. So they project themselves in what they read or what they do. So in that sense, it's not at all intelligent. It's just that it doesn't matter. We love our cats and dogs. It's like an artificial system.
Thanks, Ina. There's one very last short thing that Anna wants to contribute.
Two tiny little things. One, you could argue that piece was a wonderful public engagement exercise in ethics of AI and stuff like that. So from that perspective, people trying to hack the algorithm and make it do things is actually them learning, which is kind of wonderful in a way. And then on the other side, I would like to bring back something that I know is very central to Ghislaine's heart as well, is that if we had less bias in the people programming these things, so different cultures, different people participating, different people providing the data sets and things like that, then it might be a different situation again. So a call for more of that.
Data sets is a major problem. Bias within dirty data is massive.
Absolutely.
I'm sure you're aware of it.
I agree.
It's syncing out everything at the moment. So.
Yeah. Okay. Thank you all for attending. I invite you to come back tonight at the keynote, where the question on art and artificial intelligence will be again on the table. Welcome, please give a warm applause to the speakers, Jan Boeren, Lucas Evers and Anna Dumitriu. Thanks.